Hello, welcome. Let's try to solve another Leetcode problem 313, super ugly number. So for this problem, maybe before solving this problem, we should solve Leetcode problem 264, super number 2. And it is exactly similar because for this problem, there are going to only be prime factors 2, 3, 5. And for our problem, it is called super ugly number. We have more prime numbers, it can be more. So for example, the maximum can be 100 prime numbers, but except that everything is the array primes. Giving an integer n and an array of integers primes, so we're gonna return the nth super ugly number. So for example, n equals to 12. We have such kind of numbers. Why we have a 1? Because for 1, this number 1 have no prime factors, so it is also valid. And then for 2, the prime factors is only 2. And for 4, it is 2 times 2. The prime factors is 2. So every prime factors is inside the primes array. And also for others. So for example, let's just try to use another example. Maybe 26. So 26 is also inside because 26 is equal to 2 times 13. 2 is a prime factor, 13 is a prime factor, it is also inside. Yeah. But what are we gonna return? We're gonna return the nth number. So it's gonna be 32. It's gonna be the last number. Yeah. So this is gonna be the super ugly number, nth super ugly number. How can we solve this problem easily? So definitely from the beginning, we know that number 1 gonna be the smallest number. So if n equal to 1, definitely the final answer gonna be 1. Yeah. But what about if n more than 1? How can we find the next smallest number? So the smallest number is 1. So which is the next number that is a little bit bigger than this 1? Definitely it's gonna be this 2. But how should we know it's gonna be this 2? So we're gonna put everything inside a heap. So first of all, we're gonna put number 1 inside a heap. If we pop it out, definitely this 1 gonna be the smallest number. We are sure it's gonna be 1. So after we pop it out, we're gonna use this 1 times all the prime numbers inside the primes array. So now inside our heap, it's gonna be some numbers like 2, 7, 13, and 19. So those numbers are gonna be inside the heap. Yeah. So currently 1 gonna be the smallest number. So which one gonna be the next smallest number? Definitely we're gonna use this heap and pop it out. So 2 gonna be the next smallest number. Now we have a number 2. So if we pop out this 2, so what numbers will we put inside? Definitely we will not put duplicate numbers. So this means we can use a set to check all the numbers inside the heap gonna be unique. Yeah. So if we pop out a number 2, so which numbers will be pushed into our heap? So it's gonna always be these numbers we're gonna check. So this means that we still have 2, 7, 13, and 19. So we're gonna use 2 times 2, 2 times 7, 2 times 13, and 2 times 19. So we're gonna put all those numbers inside the heap. So if we pop out 2, so what's left behind is like 7, 13, 19, but at the same time, we just push a number 4, 2 times 7, it's gonna be 14, and 26, and the next one gonna be 38. We're gonna push all those numbers inside the heap. But currently we found the first, the second, and what's gonna be the third number. If we pop it out, definitely this is a min heap. We're gonna pop out the smallest number. It's gonna be 4. Yeah. So this is why we can get a 4. Yeah. So in this way, what's gonna be the time complexity? It's gonna be this number n times the length of the primes array, and the number n gonna be 10 to the power 5, and the primes array is 100. So the final time complexity gonna be 10 to the power 7. So it works. Yeah. If it is 10 to the power of 8, maybe it didn't work, but it is 10 to the power 7 for the time complexity. It will work for this idea. Now let's just let's first finish the coding of 264, and then we're gonna finish the coding of 313 because we just need to change a little bit. Let's just prepare the prime factors. So let me just use primes, because later on we're gonna use this variable. So the prime's gonna be some numbers like 2, 3, and 5, and I'm gonna prepare a set. Inside I can put a 1, and then I'm gonna prepare a priority queue, and I want to put the first number inside, so I'm gonna use the heap push with a number of 1. So this is all the preparations. Now let's just check for anything in range from n-1, because for each time we're gonna pop out a number, and we're gonna return the nth nth ugly number. From the smallest to the biggest, we're gonna return the nth ugly number. So from here, we're gonna pop out n-1 numbers, and lastly, we just need to pop out the last number, which is gonna be the heap pop and PQ. Yeah, so this is gonna be our final on return. But how can we pop out all those numbers? So here we're gonna use a num. It's gonna be the heap pop, the priority queue, and then we're gonna check all the numbers num2 inside the primes. So if num times num2, let's just use maybe, can I use a number? So let's just use a number, because I will use num times num2 several times. Yeah. So if this number is not inside the set, so the set gonna add this number. And we're gonna push it into the priority queue, and we're gonna use a heap push and priority queue with this number. Yeah, I think that's basically everything about it. Let me just run it to check if it works. As you can see, it works, and let me just submit it. Yeah, as you can see, it passed for all testing cases, and the speed is okay for this problem, because n is just like 1000. Yeah, and the length of the primes array is 3. 1000 times 3 is going to be a small number. That is why it works. Yeah, so for this set, do we need to use this one? Maybe we can remove this one. It's gonna maybe also works. Yeah, I think it's gonna still work, because this is just number 1. Yeah. Now let me just copy the same code to solve the our problem, super ugly numbers. Here, as we have the primes array, we just need to delete it as we don't need it. Yeah. Now let me just run it and submit it to check if it works. Yeah, as you can see, it also works. The speed is slower, because this is the time complexity going to be 10 to the power 5 times 100, which is going to be 10 to the power 7. That is why it's so slow. I think a better way going to be dynamic programming. It's going to be a little bit harder. But this, I think, going to be the first solution for the problem. By using the priority queue, it's going to be a little bit easier to understand. I think that's all about it. Thanks for watching. See you next time.